Hi, I'm Barnabuza, also known as Boise of Conspiracy, and this is Gergely Szelei, also known as Gargai of Conspiracy, and today we are going to talk about our intro system, which we use to create 64K intros. Well, some things about me. Basically, I've been active in the scene since 2000, and mainly I've been writing 64K intros. And since 2002, I've been developing this system when I wrote a set of tools together for myself, which I thought might be helpful in creating intros the way I did before. Because what I did was mostly hardcore 3D scenes and animation and everything, and it just got very bad to do it that way. So I figured I should need a texture generator, which I already had after a year, a modeler for the 3D things, a keyframer for the animation, and some timeliner tool to put everything together. So I started doing these, and well, the first thing was the texture generator, which I wrote based on Ile's article at Hugi 18. And yeah, we have the texture generator here, which is very much a copy of the ATG2 tool, so I won't go into many details, only the stuff we changed, because this is a rewrite of the original one. Okay, so the basic concept is, of course, to use commands and store the parameters for them, like we have the very basic commands, amp maps, fractal plasmas, and stuff. And these can be combined, of course, in several ways. What we did, in enhancing the original concept, was we added blend modes and channel selection, color channel selection to every command. So if we want to have more variations, we simply apply a different blend mode or a different set of channels. This I will show. If we here have a simple fractal plasma here, we have an overwrite filter, which is the basic ATG2 filter. We have an additive filter, which adds the new image to the old one. We have a subtracting filter, which does the opposite, and a multiplicative filter, which multiplies the two images. And combined with this, we could do much better textures, as seen in Beyond, our third intro. Yes. So I can show you some textures from Beyond, like these. And these have been mostly used by changing these operators. So what this gave us was we didn't have to copy an image and then do another layer copy or multiply and stuff like that, because it was embedded into the operators themselves. And that is the biggest thing we changed in the concept. We have a special operator, a make material operator for the whole system, because we needed to connect somehow the texture generator to the other parts of the system, the modeler, the keyframer, and the timeline editor. So what we did is we created this operator which builds a material list of all the textures there are, And yeah, we could basically store every step we have during the creation of the texture, but there's a 8 material limit simply because of GUI, because the GUI is limited. Okay, so I can do a texture here from this, and okay, let's go to the modeler. Modeler is basically, the concept is the same as the Werkzeug tool. We have primitives, and we can distort those primitives in several ways. But the main difference is that we have a much more user-friendly GUI. I mean by that, that what I was aiming for was, I had in my head these 4 viewport views of 3ds Max when I started writing the tool. I myself never used the 3ds Max. I only thought that this might be the good way to do it, so I started it this way, and it stayed. So what we have here are really the standard platonic solids: cubes, spheres, cylinders, and cones, and stuff like that, which can be... we have a very easy way to apply mapping to these textures. Although the limitations are that the mappings are preset. So if we wanted to do like linear mapping, we couldn't put it in on this sphere. We have the easy tiling, and yeah. If we wanted to distort these objects, we would... so we have many options to distort objects. For example, I go through all of them. The very first one is mesh smoothing I did, which is basically the implementation of the butterfly mesh smoothing algorithm, which creates this kind of smoothing. I chose this because it leaves the original vertices in their place, so the original shape and size of the object will stay the same. The next one we have is very trivial stuff called mesh blurring, which takes one vertex, takes the neighboring vertices, and blurs them like the normal pixel blur works. This makes the object go a bit like a sphere. So if I apply it more and more. And yeah, we have mapped transformations, which is basically displacement map. And so if we take this texture, for example, we can distort it with any way we want. We can also rotate, which we won't show too good on a sphere, and scale is using the displacement map. And the other thing what Zoom wanted us to do, our graphician, is to be able to go to the polygon level in using these distortion operators. And we came up with an idea to store the polygon selections in a similar way like we store the objects. So we don't store the actual selected polygons one by one, but we store an operator which has some parameters and a polygon which it was applied to. So if we want to select a polygon, we simply can select it or can select the neighboring polygons or some more. Thank you. And yeah. So we can just simply work on the selected part of the object. And we have future ideas for extrusion, but it's still on the to-do list. And we have a special object called lofts, which is basically two arcs extruded amongst each other. And this was used mostly for the pipe scenes in Project Genesis. So we can do toruses and stuff like that with this. And actually this is all of the modeler. Pretty simple stuff, but it can be used for good things. Okay. What we have here are some pre-done scenes, which are okay. So we have the layouter system. We had to redesign the animation system since the first version of the tool, because in the first version we tried to animate matrices, which is a bit hard to do. So what we did now is we store the matrix data in the modeler. So it allows us to do skewing too. And in the keyframer or layouter, we use the created scenes as primitives. And we can animate those using the standard rotation position scaling data. And this helped our problems for the animation. So we can put the scenes edited here into the modeler, the keyframer, and use them as standalone objects and animate them. The animation uses a simple spline editor, which can be seen on the bottom of the tool. It's really easy. We only have to place the object to where we want to move it, and it moves there. So this is how we can animate. We can use the camera in a similar way. So we only have to place the keyframes, and the camera can be moved easily. What we have also in the keyframer is the particle engine, which is a bit complex. It basically consists of the emitters and deflectors, and some gravity objects. So we can do some realistic gravity and particle stuff with it. Yeah, we can apply textures to these particles too. So if we want to have like small galaxies flying over here, we can do that. If I only knew which one of these is the size. So yeah, basically that's the animation system. We could animate the colors too, and well, this is what makes up the animation. And the rest of it is put together in the intro editor, the timeliner, and Gorga will speak about it.
Yeah, well, what's left is the intro editor or the timeliner, which is basically what I consider the most fun part of the tool itself, since basically this is the part where you can just put those things together, add some music and synchronize the stuff. So actually just this is the last part where you just can put the building blocks together. What you see here is something like DemoPia or Flash or Adobe Premiere or other commercial programs which have these synchronizing abilities. You have several render passes. You can put events there, but these are currently not doing anything. So you can just apply simple effects like rendering the 3D scene we modeled some minutes ago, and basically there you have an intro. Or obviously you can do some image post-processing there. All you have to do is just render the image, what you see there, to a texture, and apply some filter, like a blur, to there. And this will make it a bit odd. And obviously, since it's really funky to do that, we have also a glow filter. Our approach for that was a bit different. The widely known way of doing a glow filter was somehow getting the highlights of the image. The well-known way for that is basically turning the brightness down and turning that back up again. What I thought about applying a glow filter, my idea was basically just changing the linear ramp of colors into something exponential, which was my idea was multiplying the colors together, which can be done with multi-texturing and changing the filter kernel, which received the name contrast. So you can see how you can change the contrast by multiplying the colors and leaving all the highlights there and blurring it, rendering the thing to a texture once again, this time somewhere else, because we have some pre-rendered texture slots. Then clear the image, because we want to render it again. clear the Z buffer as well, since we may have collided a bit. You can see that the events snap. The ends or beginnings of the events, when you place them around, so you want to time them, they snap, so that you can make them fit without any further ado. Render the CD scene back again, and just render the glow back. Only with one layer. You can actually see parts of the rendering with this render pass limiting we added to the tool. This way you can see how the image will get post-processed. And this is why it wasn't good, because I removed the blur. You can see the render texture all the way through. And then just put it back like normal. And here you have the glow. This is a pretty easy way to compose a final image. Obviously, there are a lot more opportunities to do that. In PG, the city scene was used in 2 different versions. One was what you see with the window textures and stuff like that, and there was another version where you were able to see some reflections. And if with this compositing, you were able to basically fake reflections or shadows to the image just by rendering it twice and adding some basic filters. This is also the way you can synchronize to the music. This is what you see here is a frame-based timeline. Actually, 100 frame makes a second. So those are our units. The music is done by wave files, standard Windows wave files. This was our choice because we didn't want to include the synthesizer to eat up all the CPU, because the interface itself is really, really hectic when it comes to processor time. So we just play back a wave file which can be rendered by the synthesizer. And speaking of which, the synthesizer itself wasn't part of the package at all. It was used with a separate program. You may know this. It's called Yeskolabaz. It's a pretty cool program when it comes to music, because it's still somewhere between old school trackers and new school MIDI interfaces. And do we have audio? So this is basically how the music was set up. You can see a lot of the blue boxes are the things that generate the sounds, and the rest is FX, basic echo, delay, or distortion, or anything. My concept for this was making as basic music as possible, or basic machines as possible, because you can actually put like 3 or 4 of the same effect box there, and just spare basically it's just instantiation, just making as many as possible. It's good for the freedom of the musician. There are obvious some flaws and some positive things in the concept. The pro thing is you can get buzz everywhere. You just go up to buzzmachines.com and download a 30 meg pack with anything, just patches, anything, documentation, stuff like that. And musicians who aren't really into new school music, like making the new school way of music, like Logic or Reason, can be really convenient because it still looks like an old school tracker. It's just basically same way, same patterns, just putting notes and anything. So if you have a musician like we did, who wants to have high sound quality but still has that fright of new stuff, you can easily recommend him Buzz because he will like it. And also, a pro is that Buzz has a lot of fans. You can basically have a really, really large load of plugin sources, resources, example songs. So basically, you're not the first one to find out stuff like that. The cons are that Buzz crashes every second minute. Yes, if you tried it, you know. Even if your machine works right, an ugly bug is that it seems to start a rendering thread before loading the machines in. So if the loading is slow, like in our current intro, we have over 100 machines, which can be slow. If the rendering thread is really slow, then it crashes before the loading. So you have to try 3 or 4 times to actually get to the Buzz. And as you can see, one of the most annoying things was that there is no documentation whatsoever for the plugins. What you get is an H file and some like 2 or 3 basic noise rendering plugins, and that's all you have to build from. This is very annoying, but as said, there are a lot of existing plugins available, so just download and copy paste it together. One of the more artistic problems Buzz has is the low speed jitter. It's basically the problem when you want to adjust like a filter cutoff or a resonance or anything just to like make a nice sounding filter sweep, is that Buzz has this basic speed, which you, as you may saw in trackers, there's this basic speed which you can turn up or turn down, but if it's low because the sound is like something really ambient or anything, then the jittering will be really, really audible when you turn the volumes up or down. Because the problem is that the synthesizer cannot interpolate. You get render in chunks, which means if you get a new value, then the jumps will be so severe that you can hear the pops in the music. An obvious workaround for that is just turning the speed up and trying to make it as nice sounding as possible, but there's no real workaround for that. The good thing in MIDI and VST and the likes is that you can load up the resolution much easier. And since this is the last part of the whole thing, just some common tricks for the way we made our intros. We have several file formats, so we don't use the same file for the tools and in the intro. It's like using a PSD and a JPEG in Photoshop. The basic files for the editor workspace are called the DMO for the edit. This contains everything in a really uncompressed form because there's no need for compression for that. It contains like the names of the models and all the redundant data without any optimizing and such. This is same for the BMX. A good idea to use that is the chunky approach, which can be known from the 3ds files. This is basically just giving a little header and the size of a chunk which follows. And this way, if something changes in your file format, you can always load the old chunk and save the new chunks. This way, you don't have to throw out your old models in case of a version change. It's something new added. You can just load the old one and save the new one, and there you go. You're finished. The minimal data file is 2 different things. The min is the addict minimal expert. Basically, this is what you see in the intro. This is really, really compressed into minimal size. The point is using every little bit for data and ordering it in a way that it pleases the expacker. And the MVM is the music. There's the MVX music file. This is just rendering all the patterns and songs into one big stream, so it packs well. And just some little couple of 100 bytes header, which explains the music setup. Another thing which is problematic with Buzz is that, as you can see, I said there is no documentation whatsoever. The same goes for the file format. The problem is that there is a bm.txt, but which kind of explains how it should be, but it's no real relation to the reality. So most of the time of the synthesizer or making the sound engine together was actually watching the stuff in a hex editor and the tracker simultaneously and just figuring out what it does. I think I am at 80% of figuring it out now. It's not good. The GUI is fully OpenGL, as you was able to see. You can just basically add the skins and stuff like that. Just you can see you can easily implement anything into that. The upside of this is it's really, really, really flexible. You can basically do anything as long as you can code it in OpenGL. The downside is obviously that it's gets on your nerves. So just basically it's lots of time. The intentional resemblance to commercial apps like Photoshop or 3ds Max is obviously intentional because the graphicians are used to that. They like 3ds Max, and obviously the guys who make 3ds Max or Lightwave or anything, they don't make it look like that. They have their reason to do that because obviously they figured out. So it's a good idea to look like other apps because the graphicians don't need additional time for readjusting themselves to the new tool. As you see, the GUI is a bit too crowded, and there are no little names on the buttons. This might not be a good idea, since you have to write an extensive documentation for that. So we try to work around the problem, and if you look at the top here, just adding tooltips in a quasi-Windows way. So when you find a button, the upper side just shows the tooltip, and basically that's the way you can explore the interface. This is if the tooltips are descriptive enough, then basically you don't have a problem when you want to discover the tool or how it works. And we have a console for the so-called hacks when we have to fix something which we don't have an idea how to do in a clean way. And the console just works like this. And you can just add a command there which does something. You are able to, like generating the defines of a project. So you don't want to compile the stuff in which you don't use. So just add the command there and it does. And additional optimization tricks was mostly for the minimal data file was float truncation. Float truncation is basically risking the loss of precision by just cutting off the low bits. Because normally an IEE float is stored on 4 bytes. But you can mostly cut off the last byte or even the last 2 bytes without any visible, really, really visible loss. Because it's just extra precision we don't really need when you have big models. The problem can be when you have you work on a really, really tiny space when every little tenth matters. Then you can have problems. But you can obviously make it adjustable. So the tool loads and saves in different manners, considering different setups. And another thing we figured out was bit flags. It's basically some description field of what follows in the data stream. So you can sacrifice an 8-byte little header with little flags which describe which type of data will follow. So you can set a flag or set a bit in that little byte to show if a spline data follows. So if the flag is unset, you don't have to load the data. It's a really, really, really convenient way. We saved a lot of kilobytes by that. So these are basically the generic optimization tricks. Obviously, there or some stuff like using a jump table for texture generation if your filters look the same. These are common tricks. These are what we figured out are useful. And in any case, if there are any questions, then we are happily answering them.